Hey people, thank you so much and welcome back. In today's session, we are going to understand the difference between the centering and the dispersion, or centering and the variation. This is what we are going to learn. So when you talk about the centering, centering means where is the center of the data. And when you say about dispersion, dispersion will say how much is the variation in your data, whatever the data you are dealing with. So centering process we measure with respect to the mean, median, and mode. And dispersion generally we measure in the form of range and variance or standard deviation. This is the way we measure. So let us understand when there is a process and how to identify the problem with the centering or variation. Suppose, let's say you are playing a game. Maybe you are doing the gun, like as maybe shooting or maybe the archery. And let's assume this is your target where you are supposed to hit. This target I'm dividing into, let's say, two parts. This is the first half and the second half of this. And let's say, here are your some shots, or maybe the archery if you are doing. These are some shots. So these shots are spread like this. One maybe was here, two was here, three was here, four was here, let's say five was here, or maybe I'm picking up six, or maybe the seven. And let me make the four different scenario for you to understand it very easily. One, two, three, and here is the fourth one. So let's say talk about the case one. First one, looking at this data, what kind of problem you feel? You will see that data points are not close to each other. When they are not close to each other, then definitely there is a variation in the data. At the same time, all the data points only on the first half of the center. So suppose this side is your -1, here you are making 0, and this side is the +1. So all the data points are making on the positive side, which means if you take the average of this data, so average will be greater than 0, which means overall data is not in the center. So when you look from the data, that there is no value on the lower part of the data set. All the values are above the data set. Suppose you are trying to achieve something average as in 10. You are looking for as in 10 value. And your all the values are coming sometime 11, sometime 12, sometime 13, sometime 14, sometime 15. So you will never be able to achieve 10, because if one value is coming as in 12 on the positive side and the next one is coming as an 8, so 8 plus 12 divided by 2 will be your 10. Then you will get the average 10. But in this case, the case you look, all the data you see, all the values are going to be on the upper side of the center line. So when you have such kind of data, so this kind of problem, because data is not in the center, so this is a centering problem. And all the data points are not close to each other. They are far from each other. So that means this is a variation problem as well. So I see both the problem in this data set. Now I look for the second case. Suppose your data points are scattered like this. Maybe one point here, maybe another point is here, and maybe let's say another point is here. If you look at this data, what kind of problem you see? Because the data points are not close to each other, definitely this is a variation problem. They are away from each other, they are scattered. But if you look from the center side of the line, the center line is here, and from the center line, all the data points, both the side are almost, they are at the same distance. So when you take the plus or minus of this data, that will make a 0. Suppose this value is +3, so this value is -3. So +3 and -3, that will become 0. So data will make a 0 as an average, which means data is in the center, but it's a problem with the variation, right? So if I look for the centering perspective, I have no issue here. Data is perfectly in the center, but the problem is with the variation in this data set. I hope that is clear. Now let's look at the third scenario. Third scenario, your data points are maybe like this. Now, what is the problem in this case? You see, data points are very close to each other. They are not away from each other. So then definitely variation is not an issue. Variation is not an issue for me because data points are very, very close to each other. But look from the centering perspective. Are they in the center? Answer is no, because center of the data is somewhere here and all the data points are away from the center. They are not making averages in zero. So this kind of problem which you see in the case number 3 is a centering problem, not the variation problem. Let's look at the case number 4 and suppose your data points are here like this. So do we see, is there any problem in this data set, which is the fourth example? Answer is no, there is no problem, because what I am looking from my process, I am looking for there should not be any variation and all the data points are very close to each other. There is no variation. At the same time, what should be the center of the data? All the data points are in that place only in the center. So I have no issue with the centering as well. And this is what the perfect position I wanted to achieve in my data set. This is about understanding the basic of centering and variation differences. In the next session, I will explain you about what is the centering, how do we measure with respect to mean, median, and mode. Thank you so much, people. I'll see you in the next session.